Welcome to GMN Tutorials. In today's program, we're going to look at Biology GCE 2024, Biology GCE Paper 2, specifically on genetics. So, before we begin our program, please kindly remember to subscribe on GMN Tutorials and share this video so that other people can gain the same knowledge which is being offered by GMN Tutorials. Without wasting much of your precious time, let's begin into our discussion for today. The first question reads, what is mutation? So, we define mutation as the sudden change and spontaneous change in the number of chromosomes and the structure of a gene. Mutation is the sudden and spontaneous change in the number of chromosomes or structure of a gene. In the normal human body, there must be 46 number of chromosomes. So, if the number of chromosomes for a particular human being is 45 or anything above, which is maybe 47, this is a mutation. This person is mutated because anything above or below that a body can take is harmful. Hence, this person is mutated. Therefore, for the genes, suppose this is the normal structure of a gene. If this shape is altered in any way, suppose it becomes like this, becomes twisted in between here. This is the normal gene. This is abnormal gene. So this gene has been mutated because we expect this to be normal for a normal human being. Okay? Now, what are some of the causes of this mutation? Question 2, Roman numeral 2 will answer for us. State 2 causes of mutation. So, some causes of mutations, one of them is chemicals. Number 2 is radiations. These radiations come, sometimes it is being emitted from the same chemicals at some point, but most of them they come from the sun in form of sun rays, like X-rays, ultraviolet, and many more. By doing so, you'll be highly marked. Then for B, a couple with both normal skin color produced an albino. Keyword here, it's normal. Both parents, a male and a female, are normal. Explain using a genetic diagram how this would have been possible. Use the alleles A, capital letter A, which is a dominant allele. Then this one is a recessive allele to represent the genes for the skin color. So always we should be able to remember that the capital letter is always more powerful than this. This one is more powerful than this. and this one, the small letter, regardless of any genetic diagram you are dealing with, this one is responsible for causing sickness. This is responsible for causing sickness. This small letter L, small letter A. So this is the recessive allele, this is the dominant allele. Let's draw our genetic diagram. First of all, it's the parental phenotype. From the given question saying that both parents are normal, and the allele which has been given is this one and that. Now we need to use a proper proper genotypes so that a child could be sick, could become an albino. So the only expected genotypes, we are going to see them. So here it's saying normal father, closed with normal female, normal mother, parental genotype, the father is only this as normal. The mother here should be the same. These are normals. Sometimes the word they can use, these are heterozygous. This is the word they can use. Maybe here in the next paper, for you internals, they use homozygous. So homozygous is a carrying of different alleles, a capital letter and a small letter. So these are homozygous in nature. From there we cross them. Before we cross them, we separate them to form what is called the genes. To form what is called the gametes, sorry. These are what is called the gametes. From there, we begin crossing them. This one being crossed with that, mixing that. This one crossed with that makes that person. Now, see, even if this one, this small letter comes first, this one is more powerful. Like I said previously, this one doesn't mean that this one being in front, it is more powerful than this. This one is more powerful. The capital letter is more powerful than a small letter. This is the recessive allele which is responsible for causing sickness. And this one is responsible for making a normal person, like a normal man, normal father, like we have done it. Normal father, normal mother. It's because of this character of a capital letter. Then from there, we do the same to this. This is an albino, they mentioned, an albino child. So this is what is called normal. We're going to put this child is normal. Normal child. This one, we can say normal child, but this one is a carry. There is a chance that if she dares to react with the same character, a person carrying the same character, there is a chance that they can have an albino child, just like in this case we're dealing with. This one is a carrier, normal but carrier, meaning that is possessing a recessive allele, which may in future can lead to have an albino child. So here it's similarly normal child. This is the albino child. So with these are offspring F1 offspring genotype. Then this one F1 offsprings phenotype, the external appearance of an organism. So you can even see the person, we see even albinos, this is the way that's their external appearance. Phenotype, something which is the way it is looking external, outside environment. So we expect to see an albino, but for these we can't see them, but they are carrier inside. They are carriers. If you want, you can put even a ratio, say 1 to 2, these are the same to 1. So this is how you are expected to answer this kind of question. Thank you for your time to having accessed this important lesson which is being offered by GMN Tutorials. Please remember to subscribe and share this video so that other people can gain the same knowledge which is being offered by GMN Tutorials. Thank you.